All right, now, so we're going to get set up here for a little review on stoichiometry. Okay, so review on stoichiometry. And I'm going to get into I'm just going to do one question, but really there'll be 6 different answers. And again, hopefully bear with me on this one. But again, you can see how hopefully we're using 2 reactants. We move forward with the products as we go through. Okay, so let's go ahead and take a look at our equation here, the question. And what I'm going to do is I'm going to give the molar masses of 4 different things. These would be the 4 components to our balanced equation. So here we are, and it says 45 grams of sodium sulfate, so 45 grams of the sodium sulfate reacts with a certain amount of molecules of the aluminum chloride, so that's that stuff right there. And that's basically what's going on. Now, here's a bunch of questions. What is the balanced equation for this reaction? And what I'm going to do here is, we'll see how this works. Black screen. Okay, so, what is the balanced equation for the sodium sulfate reacting with aluminum chloride? Okay, so, that's previous. Okay, so sodium sulfate reacts with aluminum chloride. All right. The yellow one should work anyhow. Okay, so we've got sodium sulfate. Actually, let me go ahead and start over with this and say sodium sulfate. Well, we still might need to review a little bit with the fact that sodium sulfate is Na getting together with an SO4, so that's going to be Na2SO4. Okay, we get the 1 plus, the 2 minus, there you are. Reacts with aluminum chloride, so again, maybe off to the side, aluminum chloride, aluminum's a 3 plus, chlorine's a 1 minus, so we're going to get AlCl3. Okay, now I don't even give any more information, but we should know that this is a double replacement reaction. Since this is a double replacement reaction, the sodium will get together with the chlorine, so NaCl, and aluminum will get together with the sulfate, so we have Al2SO4 3. All right, now it needs to be balanced properly, and so let's go ahead and do that. 2 NAs, 1 Na. We better put a 2 there. 1 Al, 2 Als, we should put a 2 there. 3 chlorines, only 2 chlorines. I need to have, excuse me, not 3, that's 6. 6 chlorines, and I only had 3, so now there's my 6 chlorines. 1 sulfur, 3 sulfurs. There it is, and notice I should have probably balanced my sodiums right away. That's taken care of. And now my O's, I've got 12 and I've got 12. So there's my balanced equation for the reaction. Okay, so let's see what we can do if we can get back to it. I'm losing, it's right on there, but hopefully when we go back to the next thing, we'll be able to see it. So, how many grams of NaCl can be produced? Well, I've got my 45 grams of sodium sulfate and my 1.55 times 10 to the 23rd molecules. So, let's see here. Black screen. I'm going to go to a black screen, and I have my 45 grams. Hey, Mr. Boudreau, how you doing? So I have 45 grams of my sodium sulfate, and I have that 1.55 times 10 to the 23rd molecules of aluminum chloride. Now, I've gone ahead and done this already, so I won't have to use my calculator, but let's go ahead and solve it. I'll solve this one here in red. Hopefully the red is easy enough to see. I'm going from grams of sodium sulfate to moles of sodium sulfate. That's a 1, and then I had given you the molar masses. It's 142 for sodium sulfate. When you divide that, you get 0.317 moles of Na2SO4. I'm going to convert that to moles of salt, NaCl, because I want to compare. So 6 and 3, which in essence is really multiplying by 2, 0.634 moles of NaCl. Now, I know I'm going to solve for grams, but I'm going to stop right there because I'm going to also just check which one's my limiting reactant, and then I'll just continue with the one that is limiting reactant. So, this blue is not really great, so let me go ahead and change this to a light bright green. So there we are. So molecules of aluminum chloride and moles of aluminum chloride. 1 is the number for moles always, and of course our molecules is 6.02 times 10 to the 23rd. Again, I've done that dividing already. 0.257 moles AlCl3. Now I'm going to convert that to salt so I can compare apples and apples, so I can compare the same thing. So moles of AlCl3, aluminum chloride, and I'm going to convert that to NaCl, and I'm going to get that from my balanced equation again. Multiply it by 3, and I get 0.722 moles of salt. Okay, so I'm going to leave it at that. Now, in terms of answering the question of how many grams, I need to recognize which one's smaller. I now can compare the two NaCls. This one is smaller, so this cannot happen. So 45 grams of Na2SO4 is my limiting reactant. And if I want to figure out how many grams of salt, moles of salt to grams of salt, 1 and 58.5. Because that 58.5 is on the top, I'm going to multiply, and I get 37.1 grams of salt, NaCl. All right, so that gives me my answer for that one. Let me go ahead and see if I can get it back to that screen. Whoops. All right. And again, let me go ahead and erase this. I've got my 31, and I have all these numbers. So I've answered A and B already. I've answered the balanced equation. I've answered how many grams of salt I'm going to produce. And I've also answered which one is the limiting reactant. I'm going to leave it right there, and then I'm going to come back. The next little video is going to finish off this difficult extended question.